We're here to talk about keeping your database and the server that it runs on healthy. And we have a little experimental difficulty here. There we go. So I'm going to skip over all the intro slides and that kind of stuff. But the main thing is to start with a good configuration. If you start with a good configuration, then you can keep it healthy. And here at White Star, we have hundreds and hundreds of systems that we've been monitoring for years. We collect billions, literally billions with a B, of data points every day and evaluate those for server performance. And what that does is give us some really deep insight into what kinds of configuration options are really good and which ones are not so good. So if you're having a not so good time, we probably have an idea why that is. Guido, you recognize that? This is actually a very good production server, even though it's in parts on a table. And this actually does represent many of the highlights of a good server. I'll share the. This really was production. I walked in, sat down, and talked to Guido a little bit here, and yeah, that actually was their production server running at that point. Yes, Gus?
I think it's a fake.
No, it's not a fake.
The reason I say that is there's no dirt in it.
It was brand new. Okay, so we're going to talk about some of the best practices for configuring a database server for OpenEdge. So we're not going to talk about Oracle, we're not going to talk about SQL Server, we're not going to talk about your Exchange server or any of those kinds of things. This is an OpenEdge database server. If your ultimate goal is performance, this is how you want to configure your server. If you have some other goal, like maybe you want to save money, this is probably not necessarily the way you want to go. But if performance is where you're at, then we're going to talk about more is not always better. Virtualization does in fact have a cost. It's not free. There's no such thing as a high performance SAN. If anybody's ever bought into that, you should know better. Keep your friends closer, your clients closer. That's about client server performance. And after imaging, I hate to say it, but I still have to say this in 2023, after imaging is not optional. If you're not running after imaging, you're in trouble. That's there so that the videographer knows where to cut. Okay, so more is not always better, especially when it comes to a database server. There's a tendency when you're out there buying hardware and buying a database server, you have a performance problem, to try to treat that problem by buying more cores. More cores is probably not going to help you because you're probably not constrained by cores in the first place. Even if it seems like you might be, you're probably not. Because the OpenEdge database engine is multi-threaded. But in order to protect shared memory and to ensure that synchronization occurs correctly, the server uses something called a latch or a mutex lock, which is a single-threaded bottleneck on operations against shared memory. And that makes a choke point, kind of like this traffic circle here where everybody's all coming together trying to get at the same resource. And you can't fix that by having more cores. You can fix it by having faster cores. And fewer of them is usually good. So less traffic moving faster is going to be more efficient than a whole lot of traffic moving very slowly. Yes, there's a speed limit. It should be raised. There's a, sorry?
So is NUMA still something that you know as a challenge?
We will discuss NUMA in a moment. In manufacturing, there's a trade-off. So when Intel or AMD or ARM or somebody is putting together a new chip, they make a trade-off for the core speed versus the number of cores that they can put on that chip. The more cores you have, the slower they're going to run. So if you go out and buy a 24-core CPU, it's going to be slower than an 8-core CPU from the same family and the same generation of those chips. So generally speaking, when you look at the product offerings, you'll see that relationship. The total number of cores is related to the frequency that you can run the chip at, and the more cores, the slower that chip is going to be. So you generally want a smaller number of cores running at a faster speed. You'll get better throughput that way. Here's where we talk about NUMA. This is for you. You can't fix the problem with NUMA. Now, your manufacturers want to sell you NUMA because that costs more money, obviously, so they make a better commission. They have better results from their sales efforts that way. But that doesn't help you with your database because you're spreading the load wider, so you have more lanes of traffic, and worse yet, you have more stoplights. And what happens is when you are spreading that load across all those CPUs, it has to coordinate, and it has to make far memory accesses. So instead of accessing memory on the same core, it now has to go over the bus and out through the neighborhood and then come back onto another bus. It's almost like a SAN. And that all takes time. So here we have some testing that we did last year, looking at the number of records per second that you can read in various configurations. So the top line is basically one NUMA node. So that's just one node. The other three nodes are turned off, and we get the best throughput. We got about 3 million reads per second with just one node. So disable the other cores. As soon as you cross over to that very first CPU on the second node, performance plummets. Drops right off a cliff. You get half the performance as soon as you start using any core on any other node. And no matter how you mix them up, no matter what you do in NUMA control, no matter what you do trying to spread things across the other cores, you only get half the performance when you're using more than one node. When you look at the NMON data over here, you see that there's a boatload of system time. That's the coordination going on between the nodes. And this is with all of them enabled. This is with only one enabled. So basically what happened here was we got twice the performance at a small fraction of the total CPU utilization. So by turning off 24 cores, we doubled performance. The accountant hasn't heard about this yet. But the users are really happy. I do have to check in every couple of weeks and make sure nobody accidentally turned them back on. Okay, so virtualization. A lot of you have virtualized environments, probably most of you, I would think. Anybody running on bare metal? Okay, Gus. Yes. Okay, we got one smart person in the back. Excellent. So if you're running a virtualized environment, one of the key things is to not over-provision it. Don't put more stuff on that server than it could actually run if everything ran at once. Because what will happen is that the individual VMs will compete with each other. They'll need to get scheduled. From within the VM that your database is running in, it'll look like you're not doing a whole lot. It'll look like you're actually pretty quiet, sleepy, not a lot happening, not a lot of demand for CPU. But what's really happening is that the hypervisor is having trouble scheduling you. And that might be because you have too many VMs on the physical server. It might be because the one that you've defined is too big. And you basically, so you have an 8-core VM and you got a whole bunch of little 2-core VMs. Guess who gets scheduled first? The little 2-core VMs get scheduled before the 8-core because it's easier to do that. But you also don't want to exaggerate. You don't want to go to IT and say, hey, I need this great big giant VM because I got peak processing and I'm the most important application out there. No, you want to size it for what you really need. You don't want to overdo it. You don't want to underdo it. You want to get it just about right. The penalty can be as high as 50%. Can be. That's not to say it will be, but it can be. You can suffer quite desperately when you have a over or under provisioned VM. Hyperconverged, everybody know what hyperconverged is? That's software defined everything. So basically yet another layer to make things even slower. Nutanix, anybody got Nutanix? That's the worst of the bunch. Anyway, nothing could ever possibly go wrong with software controlling your system, right? Because we're all software guys and we know how well software works. Trust our lives to Yeah, so virtualization, not free, not cheap. Okay, there's no such thing as a high-performance SAN. Mike, I think that's a phrase I stole from you. Anybody have a high-performance SAN? Anybody try to have a high-performance SAN? The problem with SANs is that the data has to go through layer after layer after layer. So your CPU needs some data, and it's going to try to get that data. It's going to make a request to a disk controller. The disk controller is going to take that request and it's going to put it on a network controller. The network controller is going to put it out on the network, and it's going to go through a couple of switches and fabric and whatever all you got, and then it's going to get to the SAN. The SAN's going to read it, and it's going to go to another disk controller. And the disk controller is going to go out to a RAID controller, and then it's going to get the data. And now it has to turn around and go the other way with all that data. So there are a lot of steps, there are a lot of layers, and a lot of latency for that data to get from the disk to your CPU. And you can't solve that problem by having an all-flash SAN, because the flash is in the wrong place. It's at the wrong end of that cable. And the cable, even if it's fiber, what's the speed of light? The speed of light is 1 foot per second, or about 30 centimeters per second. And that's in a vacuum. In fiber, it's 2/3 of that. And there's nothing you can do about that. There's no magic. You can't make anything go faster than the speed of light, so you're stuck. So everything gets involved, slows things down with your SAN. So your fastest storage is going to be your internal solid-state drives, some sort of SSD variant on that. It's also cheaper than a SAN, by the way. So, you know, if you're cost conscious, go with internal storage. It's way cheaper. The only problem is that your storage administrator might have to work nights and weekends once in a while. So one of the main reasons that people use SANs is for ease of administration. Basically, you can do things more readily and from a central console. You don't have to go to the individual servers. You don't have to have logins here, there, and everywhere to do it. But the problem with that is you can make mistakes really easily in a central location as well. We had a customer in the SAN administrator, what was his name? It's hard to remember because he's not working anymore. But he was doing a migration, and he was getting ready to do the migration, and he wanted to test something, and that involved wiping out all the LUNs for the test database. And I was at lunch with the IT manager of that particular company, and everybody's phones went off all at once. Production's down. Why is production down? Nothing should be happening. Well, production disappeared. What do you mean it disappeared? It's gone. How could that be? Well, we got back to the office and we found out that the SAN administrator had deleted production, not test. So, just a lesson. Keep your friends close and your clients closer. The only thing that is slower than a SAN, you might think that a SAN is the slowest thing imaginable, but there is actually something slower. It's called a network cable. And your application probably uses a lot of find statements. Do we have anybody here whose application does not use any find statements? Good, because I would have to wonder about that. You use a lot more find statements than you do the for each no-lock queries. Progress has done a ton of work on improving query performance. For each no-lock has become orders of magnitude faster than it used to be. So when you go out and you grab a bunch of data and you want to do a report or an inquiry or something like that, you get that data like that, much, much quicker than you used to in a client-server environment. The problem is that the find statement has not been improved, and it really can't be, because a find statement is a single record. You're going out, you're asking the server for a record, the server has to send the record back. That's two or three messages. Technically, I think it's 3. There's a request, a response, and then the cursor gets released. And each of those is going to take a fraction of a millisecond. Well, a fraction of a millisecond is an enormously long period of time, right? And those add up, a couple hundred fractions of a millisecond, and all of a sudden you're looking at time that people are actually going to notice. So if you're going find in a client-server environment, that's going to slow you down. You want to do things that will avoid that. And one of the best things that you can do, well, we'll get to that. So comparing shared memory to client server really is pretty radically different. So you can run, 400,000 records per second in shared memory, or you can do a couple thousand localhost. The difference is enormous. If you have to be client server, the thing that'll make the most difference is your ping time. So these are different client server scenarios with different ping times. You get much better throughput on localhost, even though it's client server, TCP IP sockets, all that kind of stuff, because your ping to localhost is 0.017 seconds. Your ping to an actual physical LAN, local LAN right next door, is 0.058. But there is an anomaly here. You see this throughput for this guy, the 4 each joined with a table scan, is actually much higher in client server than it was for shared memory. It didn't even show up in shared memory, it was so slow. Why is that? Well, because, yeah, why is that? Bad, really bad. How bad can it be? The difference is because in client server, you have two separate processes which are actually cooperating. So you've got the client and you've got the server, and when you're streaming a large amount of data, the latency gets lost in the startup. So the streaming of the data is what you see there because there are two processes doing it. When it's in shared memory, there's only one process doing all the work. So you don't see the throughput as quickly there. Now, client server, I mentioned here, these are local results with the ping time, 0.058, 0.069. I tried to run the benchmark on a non-local example. And that benchmark had a 35 millisecond response time. When I ran it, after 18 hours, I killed the benchmark because I didn't have any results. So it was way worse than running locally. So what are some of your solutions? Well, you can use shared memory, and that works if you have a good old character client. You know, anybody still have a good old character client? Excellent, excellent. You are the good people. You can get great performance because you don't have to worry about client server. You can move your code into a classic app server or PAS-OE and run those in a shared memory configuration to do your finds and your for eaches and all that fun stuff. You can minimize ping time. If you keep in mind that 1 millisecond is not really good. 1 millisecond is a server that's 100 kilometers away. So that's not really local. If you're within the same data center, then you're in that 0.0 some odd millisecond kind of range, then you're probably okay. If you're running in Azure, then you want to use what's called the proximity placement group. That's Azure's term for two servers that are right next door to each other. And yeah, you have to pay extra for that. Or if you're in AWS, you can use something called local zones, which is the same thing. There are servers that are right next to each other, probably in the same rack, and they'll have very good ping times. Other things that you can do to improve your find latency are to try to address the find by using a temp table instead. An awful lot of that find traffic that a lot of applications use is really, it's control records. A lot of them are read-only records, and a lot of them are, not all of them, but a lot, are in small tables that you just read over and over and over again, one record at a time. So build a temp table, put it on the client, and do temp table finds instead of database finds, and you'll reduce a lot of that traffic that way. It's a good strategy. Okay, it's 2023. Can anybody afford to rekey a day's worth of work? Not only can you not afford to do it, you probably can't actually do it because you don't have the paper trail anymore. 10, 20, well, not even 10 years ago, 20 years ago, you probably had a paper trail. You could go out on the floor and you could find pick tickets and receipts for things, and you could probably put them back in. You can't do that now. That stuff doesn't even exist. So you basically, if you lose your data, you're out of business. You have no way to recover. After imaging allows you to do roll forward recovery to a point in time. So you have the after image logs, you rebuild the database, you roll forward to the recovery point which is wherever your last after image log was. You don't lose 24 hours or a week's worth of data. You're back in business. Might take a minute or two while you get there, but you'll be there quickly. What you don't want to be doing is taking snapshots with your VM or your SAN. VMware snapshots, Beam, or any of the SAN snapshotting things, they don't know about OpenEdge. They don't know how to synchronize an OpenEdge database, and they're not going to do it right. It'll work great in your test environment. You'll think it's wonderful. You'll try it, you'll test it, you'll restore it. Everything's wonderful. But you know what? Your test environment isn't real. When you do it in production, that's when you're going to make that phone call. Oh, my database is corrupt. What can I do? And you're going to find out you can't do anything because your database has been corrupted. And if you don't have the after image logs, you're out of luck. Nobody's going to be able to help you. And unfortunately, people keep making that mistake. We get a couple calls a year about this. People who didn't have their after imaging turned on, and now they want some help. Mike, how many did you used to get when you were MDBA? Right, true. Yep, right. Yeah, a few times a year, you'd have that. Yep. Yes. vMotion, yeah, same issue. Yep. It looks like it works great in your test environment where you don't have a whole lot of volume, but falls apart afterwards. James. Yeah, so there's real user experience back there. Yes. Nine out of 10 really isn't good when it's your database integrity. Exactly. So yeah, so you need to have a ProQuiet, but you got to do ProQuiet correctly. So you can't just issue the ProQuiet command and assume that the database has been quiesced. You have to issue the ProQuiet, and then you have to monitor the log file to ensure that the quiet point actually took place. They don't always take place right away. Can be a gap there. So if you ProQuiet and then your script makes a snapshot, you're not getting what you think you're getting. And even so, you would want to have after imaging, because after imaging is not just about database crashes and hardware failures and that kind of thing. It's also about fires, servers getting stolen. That really happens. People back up trucks to data centers and fill them up with servers and drive away with them. Human error, RM-RF star. You laugh. I know of cases. It's happened. Or for each order line where line number equals 1, delete order end, kinds of things. Or I had a programmer who once did this. They were writing an update to some lending software where the function that they were supposed to be implementing was to delete a borrower. Well, they forgot to put the loan number in the where clause. So the first time an end user went to delete borrower number 2, they didn't delete one borrower number 2, they deleted all borrower number 2s. Yeah. Yes. Yeah, and after imaging will save your life so many different ways. It's really it's an important thing to have in any production environment. You really need to have it. It should be on by default. Another thing to remember is that the ideal database server is not alone. So if you get your server configured the way you want to have it, it shouldn't be the only one. In the modern world, you really need to have a DR server, and you probably need high availability if your business is of any significance. So you probably want to have replication. So you have the server, you have a replication target, you might have a disaster recovery target alive in real time, located somewhere else, hopefully in another time zone. You want it far enough away so that everything doesn't all fail at the same time. Having your DR, your HA, and your production server in the same rack is probably not a good idea if the one on the bottom catches fire. They're all going to go up in flames at the same time. Oh, yeah, the same virtual host. Yes, an excellent plan. Yeah. And you probably want a full-size test server, because if you're really into this kind of stuff, you need to test things. You need to do testing as if it's production. You need to test the same way you run in production. If you don't, then what are you really testing? And how do you ever test that your failover and your DR policies are really correct, unless you have a test environment where you can try things out? Yes?
So the test environment, the test server needs to be configured the same as the production server too.
Yes.
I had a question with you guys, RAID 10 storage for the production machine and RAID 5 for the test machine. What happened?
Well, it can sometimes be the other way around. There have been plenty of situations that we've come into where somebody is having production problems that they're sure are because of a misconfiguration of their OpenEdge environment. Production is slow, but my test system is really fast. Well, yes, that's because your test system doesn't have that high performance SAN. Your test system has internal disk. That's why it's faster. Happens all the time. So the ideal database server has a relatively small number of very fast cores. You need at least 2. You almost certainly don't need more than 8. There are people who need more than 8, but there aren't very many of them. So most of you need somewhere between 2 and 8 cores. I have never seen a database server that actually needs 48 cores. I've seen lots of database servers configured with 48 cores, but I've never seen one that needs 48 cores. You need plenty of memory. In today's market, 64 gigabytes is an afterthought. It's what's on your watch. If you have, a watch, an Apple Watch or something like that, you probably have 64 gigabytes in it. A terabyte is starting to look like the low end of a server purchase these days. You get a lot of memory at a relatively inexpensive price. And you should plan to use 25 to 50% of it for your buffer cache, because big buffer caches are way more performant than small buffer caches. If you have dash B 100,000, you're not even trying. If you have dash B 1,000,000, okay, all right, that's good. That's a good start. Let's keep going. You can go much higher than that. Internal SSD. If you're all about performance, you need internal solid-state disks. It will be radically faster than any SAN that you will ever buy. It's also cheaper, as I keep mentioning. And if you have no idea how your database is going to grow, just assume it's going to be 10 times bigger in a couple of years than it is today, because data growth is out of control. Everybody's data is growing wildly for all kinds of reasons. You're logging things, you're putting notes and things into your database, and it just gets bigger and bigger and bigger every time you turn around. And it doesn't do you any good to try to purge it, because the demand for putting more data in there is faster than you can purge it. You need a couple of fast network interfaces, one for the users and another for administrative things like replication or backups, that kind of thing. Also for redundancy and failover. You don't want to have just a single point of failure. Dual power supplies. It's really wonderful to be able to pull a power supply out of a server or pull the plug out of the wall while you're moving the server. You kind of move it down the hallway, plugging things in. It's really fun. The first time I did that, I really didn't believe it was going to work. But it did. That was great. Okay. Another one for the videographer. Okay, so how do you keep it that way? Once you've got this server that's running the way you want it to, you got to keep it running good. So now we'll talk about a little bit of that kind of stuff. So first of all, you want to make sure that you're recoverable. That means that you need to verify that you have a successful backup. Don't just trust that your cron job or your scheduled task is working. You have to verify it. You want to go into the log file and you want to see that magical message about full backup successfully completed at the appropriate time every day. And you want to keep track of when is the backup finishing, because backups that are taking longer and longer to finish are like a canary in the coal mine of a problem that's starting to emerge in your I/O subsystem. If you have a bad disk and things are slowing down, or you're storing more and more and more data, then that backup time is going to move every night. It's going to keep creeping back. And before you know it, it's going to be 9:30 in the morning and you're still backing up. And that's got something to do with why the users are not happy first thing in the morning. You need to verify that after imaging is actually enabled and the extents are actually switching on time, or whatever your schedule is. You're either doing it on a time schedule or you're doing it because they're filling up and it's time to move into the next one. Personally, I usually do it on time because I like the predictability of that. Take note of how long the BI backup phase takes and how long AI copies take to complete and be copied to the archive location. So another indicator that you're starting to have either more data being added to your database faster than previously, or you're having I/O problems, is that the length of time to copy an empty full extent to the archive takes longer and longer and longer. It should only take a few seconds, 30 seconds, something like that, for a pretty big one. If it starts taking multiple minutes, then you know that things are either way bigger than they used to be, which might be a programming problem. Maybe you've got too many transactions going on. Or you could just be having data growth, or you could have an I/O problem on your target. And you want to verify the replication status on each server. So if you have a replication source and a replication target, DSR util status verbose normal on the source does not mean that you'll get the same result when you go to the target. There have been issues with one of them thinking you're in normal processing and the other one saying, no, I'm not connected, I'm waiting, something's not happening here. You have to check both sides. You can't check just one. So you want to verify that your offsite backups and your archived AI logs are getting there, because these are your recovery if anything ever does go wrong. You need to make sure that you have that backup going somewhere out of the building, so that if somebody steals your servers, or the building burns down, or where's Adam? Adam deletes all your databases. You want to be able to recover from that, and the only way you can do that is to have the after image logs and the backups somewhere else. They have to be on another server. They can't be on the same server. So you've got to confirm that they've been copied, that the date and the timestamp are up to date and as you expect them to be. You may. Well, yeah, I've got a pretty good example of that. I have a customer who has a database that's about 2 terabytes, and their offsite backup goes offsite every night. So we make a backup, it's a little under 2 terabytes, and every other night we do 2 different targets. And on odd numbered nights, we do the uncompressed backup alone. On even numbered nights, we do an uncompressed backup and we gzip them and ship them to the other location. So I have both the compressed and the uncompressed every other night. The compression doesn't take long. I think it takes like 45 minutes or something like that to compress all the backup extents. The transfer, because the compressed files are smaller, is much faster. But if I need to use that backup, I pay the price then because the target, the backup depot, I guess you'd call it, is in Azure, where we have SAN storage. And it takes approximately 16 hours to decompress the compressed backups. And then it takes another 16 hours to create the database from that. So it's more than a day to restore from those compressed backups, whereas I can just use the direct ones, the uncompressed ones, much more rapidly, and then I can just start rolling forward AI files, and I'll have the AI files rolled forward faster than I would have the database uncompressed and ready to use. So yeah, it's a good point. Yes?
So, and by compressing you mean like gzip, and
That's-
not the minus com parameter?
Both. So I use the -com parameter, and then I gzip them. But in point of fact, it doesn't make much difference. If you don't use com and then you gzip them, it's pretty much the same size. Yes? No, yeah, so if your database is encrypted, to the extent that it's encrypted, you're not going to get much in the way of compression. Right, at that point, there's not much point in compressing if you're encrypting. Yes, Rob? Rob differs.
Because even if you're compressing every logical object in your database, it's still only index blocks in most of your record blocks. And there are a lot of other block types.
That's a good point.
Whether it's metadata or free blocks or empty blocks that are not compressed. And they'll still benefit, that are not encrypted and therefore benefit from.
They're compressible, yeah. That's a good point. So for those who didn't hear that, Rob's pointing out that not everything in the database is a data block or an index block, so it will compress even if you're using encryption. I'm not sure what the percentage, though, is going to be. It's going to depend on your database structure and how much space you've pre-allocated to storage areas and things like that. But there would still be some compressibility even though you're encrypting a lot of the data in the indexes. Whether it's enough to make it worth it, I'm not so sure. There's also new, yes, Gus?
Most people's databases do not need to be 100% encrypted. There's often data that's perfectly fine unencrypted.
Rob's got to talk all about that later on. James, you had a question? Yes. Yeah, so there's a new, do you remember which release that is? 12.5? Rob says 12.5 has compression with the backup now. It's part of the product feature, so you don't have to do it as a separate stage, which is kind of cool. And hopefully it saves a little I/O, makes the backup a little faster, offloads some of the work onto the CPUs rather than the I/O subsystem. Okay, so where were we here? Oh yeah, verifying offsite backups and AI logs. Okay, so you're recoverable. Now you want to keep it that way. So some of the things that you need to do on a regular basis, you might do this every day, you might do it weekly, but you want to check the BI file size and free space on the BI file system, because you don't want to run out of space for your before image file. That would be tragic, because if you have to go through crash recovery, the BI file will grow. You have to have enough space to recover from recovery. So the rule of thumb is that you want your BI file system to not be more than about 25% full so that you can recover from recovery. Make sense? Everybody's clear on that? You want to make sure that you got plenty of space in your AI archive file system. We had an issue recently with a customer who all of a sudden their AI space was growing dramatically. It was growing, I think it was about 25 gigabytes per hour out of nowhere. It was usually stable because we were keeping a fixed length of AI files there, and all of a sudden the AI file space starts growing. What's going on? Well, that keyed us to look into why do we have this growth? Where are the transactions coming from? We discovered that there was a table that was suddenly growing. So this table in the application started growing on a Monday. Wonder why it started growing on a Monday. Hey, did you do a software release over the weekend? Yes, we did. Did it have anything to do with this table? Yes, it did. You might want to look at that code. And they did. And sure enough, the code was, what is that term? Crappy. So anyway, they would have run out of space by Thursday, but thankfully we caught it on Monday. Check your free space in your backup file system for the same reasons. If you can't fit the backup on the backup file system, then you're not going to have a backup. And if you're not checking your log file for a successful backup, you might not even know. We've run into more than one customer who didn't have backups because they weren't checking for the success of the backup. And they thought everything was great until they went to restore a backup. And then they find out, no. And by the way, these are people who usually call who are not customers at that point in time. They're looking for help. Customers that are already customers, we try to make sure that this kind of thing doesn't happen. That's part of our deal. If you have offsite depots, you need to make sure that they have sufficient space. And things grow. Remember, things grow. So you can't just allocate a backup depot and then not touch it for 10 years. That's not going to work. You're going to run out of space a lot faster than that. And you want to refresh your ProStruct list every night because you need that ProStruct list if you're ever going to do a restore into a similar structure to what it is you have. Yes, Gus? Yes. Yeah, okay, I didn't have a slide for that, but yes, you're right. So usually your backup, you want to have the backup, you want the ProStruct list, you want the key store if you're doing things with encryption. You may want to throw in the SSL certificates if you're doing any of that. The backup isn't just the database backup. There's a lot of things that go with your backup, depending on how complex your environment is. Your REPL properties is another good thing to back up because that's a little tricky to replace if you ever need to. Some of the logs that you might want to look at. You want to look through your logs, nightly, weekly, something like that, depending on how busy you are, to see if there's anything in those log files that is problematic. In particular, error 49. Error 49 is always a progress bug. You should always report error 49 to tech support. It's always, always, always a progress bug. I learned the hard way. I didn't report something for a long time because I thought it was my fault. Yes? There's no such thing as a hardware problem. It's always software. There's a feature called diagdir. This is for the diagnostics that Progress will generate. Anybody ever have a lock table overflow? Okay, we've had a few lock table overflows. Diagdir is this great feature which will dump some very useful diagnostics on certain conditions. It does it for lock table overflows, for system errors. What's the other one? BI threshold. Yeah. It's configurable how much detail you get. You get either a summary or you get some details. You can get stack traces and fun stuff like that. But it gives you enough information to be able to figure out what caused that problem, which is often really difficult with a lock table overflow. The lock table overflow, you get a message in the log file, but it's the victim. It's not the person or the session that caused the problem. It's the session that ran into the problem. And you need that diagnostic dump in order to figure out what happened here that caused this to be an issue. And diagdir is great. So you can just check to see, do I have any new entries in that directory? If you have new entries in that directory, then you got something you can go look at. If you're monitoring metrics, then you want to be looking for trends that are approaching actionable thresholds. So that's things like file systems filling up, or the number of users is rising and you need to call up sales and order some more licenses. Is there anybody from Progress Sales in here? I want brownie points. Okay. Don't forget to look at your app server log files. There's a lot of stuff that goes wrong with the app servers that if you're not looking in the app server logs, you'll never know about it. And you'll want to have some knowledge about that. Whoops. And then, of course, you want to see if there's anything that is actively going wrong right now. So do you have a lot of overnight processing that should be done by 8 o'clock in the morning but is still running at 11:30? That kind of thing can creep up on you. You know, you have a job that used to finish at 8 o'clock, then it started finishing at 8:05 and 8:10 and and all of a sudden it's finishing at 11:30. How did that happen? It takes a long time to see those things sometimes. Long open, anybody have an open transaction problem where they have transactions that are hours old? Oh, come on. It's a big problem. So you want to be monitoring for transactions that have been left open, that are consuming a lot of BI space or potentially consuming a lot of BI space, and figure out what you can do about them. Unusual high activity processes. These are processes that are suddenly doing a lot more work than they used to do. Maybe it's a inquiry function that is being used by a lot of users, and all of a sudden you got way more active system than you used to have. Long-running jobs for memory leaks. So we heard John this morning talk about memory leaks. If you have classic app server, you have a small memory leak, it probably isn't a big problem because you restart those app servers fairly regularly. While you move to PaaS-OE, now those are long-lasting processes and the memory leaks pile up. So you got to pay attention to anything like that that's happening in your environment. Even if you're still on classic app server, you want to pay attention to that because you're going to have to migrate. And when you migrate, those things will become problems. So cure them now, not later. In the morning, even if it's somebody else's job, look at the OS logs because your sysadmin might not be looking. You may have errors popping up telling you the disk controller is about to go bad. You might have some memory that's reporting errors. Check those OS logs periodically. Make sure that somebody is paying attention to that. Check to make sure you have free memory. One of the things that happens a lot on Linux servers is we'll have somebody with a Linux server. It's been running for a while. Somebody on the admin team who doesn't usually take care of that server logs in and starts X Windows. All of a sudden, you got 12 gigabytes of memory being wasted by an X Windows session that nobody's even running anymore. So, look at that kind of stuff. Look at the previous day's CPU and disk utilization. Is that normal? Do you see the same pattern that you see every day, or are you suddenly seeing a lot more CPU utilization or a lot less, or difference in the ratio between system use and user use or something like that? Keep an eye on those things. And then, of course, pay attention to the configuration of the OS. Did somebody apply some patches and not tell you about it? That would be unfortunate. Especially pay attention to that on your SAN. Happens all the time. People make SAN changes. Or your virtualization, they might vMotion your server from one host to another host with a different configuration of CPUs and RAM, and all of a sudden you're not running the same way you used to run. That's not really good. This is one of the most important things you can do. Every morning, check your email. Check the PANS report. This is Progress's knowledge base update that goes out to every Progress user who signs up for it. It lets you know about all the new bug reports, all the new things that are happening in the K-base, and it's surprising how much you can learn just by reading the titles. You don't even have to click on them. And you learn all sorts of interesting stuff that might be happening in your environment. If you have not signed up for PANS, it's easy to do. How to subscribe. There's a knowledge base entry on it. You just look it up, put it in the search engine. How do I subscribe to PANS? And that'll take care of it. Is anybody not subscribed? So you're all reading it. Oh, okay. When you get home, subscribe to PANS. You'll get an email at 9 o'clock European time every morning. I think Ruan might send them out. I'm not sure. But somebody in Rotterdam who sends them out every morning. I'm quite sure about that. During the day, you want to kind of keep an eye on what you have for long open transactions, whether the BI file is growing. Because, if your BI file grows and fills up the file system, the database crashes, Users are going to call, and they won't be happy. You want to look for blocked users and connections. So you're looking for anybody who's blocked on a record lock for any significant period of time. That means that they're having issues with somebody has record 123 locked, tells you who the user is who has it locked, but you can't usually get them when you call them because they're not answering their phones. Nobody has a desk phone anymore anyway. You're looking to see whether the BK and TX system resources have any constraints on them. You're looking for any excessive activity or rapid readers. You're trying to figure out what they're doing, what's different about this, why is this all of a sudden happening. Sometimes it's legitimate. Sometimes management came down and said, hey, by the way, we're buying a competitor next week. We got to put together such and such a report. Can you do it right now? Okay, that's legit. You got to do that. But if it's just routine business operations that are all of a sudden consuming a lot more resources, then you probably are dealing with the wonderful programming team released a software update and did something wrong, like maybe they forgot the where clause. Who knows? It's been known to happen. There's a feature that I'm going to talk about tomorrow called the client statement cache, which you can use to identify specific code that is causing the problem. So if you see that a particular connection is very active, you can use the client statement cache to find out what code they're running, which is great when you go back to the programming team because now you can tell them exactly where to look. Instead of describing the problem, well, I think there's a lot of activity in the order table, but I'm not really sure what they're doing, you can say, there's a lot of activity in the order table, and it's from order.p line 1, 2, 3, 4. Now they've got something they can sink their teeth into and they can fix. It's a fabulous feature. Periodically, you want to rotate and truncate the log file because it's a real pain in the neck to have to deal with a multi-gigabyte log file. If somebody comes to you and they got a 100 gigabyte log file, but they had a problem yesterday, that's a real pain in the neck. So truncate that thing every now and again. Weekly's good. Clean up the trash in your database directories especially. It's amazing how much junk files you can accumulate over time. You'll find copies of this and copies of that, this .save and that .fred and so on and so forth. Get rid of that junk. Either delete it or move it somewhere, do something. Just don't let it pile up forever. You'll have leftover ProTrace files, leftover Scratch files, the core files, and the -t directory can get filled up with junk too, especially if you're using the lowercase t parameter to make the temp files visible. So anytime a session ends abnormally, its Scratch files will be left in that big T directory, the session temporary directory. You'll need to refresh your DB analysis on a regular basis. It's really helpful to have a DB analysis that tells you how big your tables are, how your indexes are doing, how everything is organized in there, and all the statistics that go with that. Now, we used to tell people that you might run that monthly during the middle of the night. And sure, you could do that. I have lately taken to running it nightly, and I'm at 5 minutes. I run it nightly at a lot of customers now because if you have a decent I/O subsystem and the database is performing well, it really doesn't take that long. You can run it in an hour or so against a multi-terabyte database if you have a good, healthy server. It doesn't have to be something that's going to take 12 hours to run. And it's really nice to have that data every day if you can swing it. It does run everything through the cache, but so does the backup. So, you're so, pluses and minuses. But if the system's fast enough, that's probably not a big problem anyway. Refresh your dev, test, QA, training, those environments. A lot of environments, the testers like to work with real data. So they take a production database, they restore that in a UAT environment or something like that, and use that data for testing. Now, sometimes that data gets processed to make it less personally identifiable. That happens. Progress is looking into a feature called data masking, which will also help with that. But whether you do that or not, there are a lot of environments where you're refreshing a test environment from production so that you have realistic data to work with. And if that's something that happens in your environment, you need to schedule that. Make sure that that's part of your routine. When you do look at DB analysis, some of the things that are really good to do are to look at the index utilization and identify targets for index compact. Patrice has got a talk Friday about deleted key placeholders, which really kind of highlights what many of the benefits of an index compact are. That's a good talk to go to if you're interested in that kind of thing. You want to check and make sure that your index or your rows per block settings are correct, that you're not having data which is drifted over time. You might have originally put it in a storage area that was well suited for that data, but the data may have had a bunch of fields added to the record, and maybe you added some indexes and things have changed, the record length has grown, now it should go in a different sized area than what you've got it in. Check the RM chains. A long RM chain is indicative of certain sorts of problems that you might want to try to avoid. A bad match between the rows per block and the storage area. Scatter. There's two kinds of scatter. There's physical scatter and logical scatter. Physical scatter is reported by the DB analysis. Logical scatter you have to figure out for yourself. But that's basically either how tightly packed the records are or how well the ordering of the records matches the ordering on disk. And then, of course, you're looking for growth in your tables, your indexes, your lobs, any of those storage areas and whatnot. And schedule whatever remediation you need. You want to look at startup parameters periodically. So you want to go through and make sure that you're not using old startup parameters like -E. Anybody still using -E in their PF files? I think that chuckle might mean yes. But you want to basically you want to make sure that your parameters are matching your actual utilization of the OpenEdge environment, and that you're not using old stuff that isn't there anymore, that somebody's at least taken a look at it once in a while and made sure it's appropriate. Check your SQL connections, run dbtool if you need to, or if you can use autonomous data, whatever it is, the autonomous update, thank you. And run update statistics for the SQL optimizer once in a while as well. If you're using SSL, you need to pay attention to whether your certificates are about to expire, because your users will tell you if the certificates expire. So you want to be out ahead of that before the users call you up. Look at the OS, kind of like you did before. Look at the kernel parameters, make sure that you're patched, make sure that nothing bad has happened with I/O throughput, that your random reads and your synchronous writes are where you expect them to be. This is a great time quarterly to look at your progress release level. Do you want to be on an innovation release? Do you have a service pack for a long-term release? Is there anything that needs to be done about any of these things? Is there any planning that you need to do to get on to whatever the next release is going to be? Whatever you're monitoring, you want to look at those things, and then make sure you talk to the business people, because the business might have some plans that they haven't shared with you. It might not be, and they might not be willing to tell you that they're about to acquire a competitor, or maybe a competitor is about to acquire them, but they often have other things going on, like marketing campaigns, where sales is going to go out and they're going to sell a whole bunch of a certain product, and it sure would be nice if you knew that in advance so that you could monitor the appropriate back-end processes that need to go with that sales process and make sure that they're in good shape. Sales will never, ever, ever in a million years think to tell you about that ahead of time. They'll complain about it the minute it doesn't work, but they'll never tell you about it ahead of time, unless you ask. If you ask, they'll tuck your ear off. You should do a DR test at least annually. Anybody do a DR test? Great, great. One of the best ways to do DR testing is to have replication sets where you have a source and two targets, and you just rotate. And just do that every 6 months or yearly or whatever, and you just change which one is the real one. And then you know that your DR really does work. It's no question about it, it works. Look at the hardware. Oh, yeah. Progress sales. I want brownie points here. Look at your licensing. Make sure that you're properly licensed and true up with the sales team to make sure that if you need more licenses, if you need products that you don't have, that you acquire those. And then review the hardware landscape, any potential upgrades that you might want to do to your servers, see what's been going on in the marketplace there, business growth, and of course, you want to come to Pug Challenge or Exchange every year, right? We're all smart enough to do that. Okay, so that's it. Do we have any questions? Hearing no, oh. Yes, that's the autonomous data update. There are actually two. There's, yeah, what's ASU stand for? Autonomous schema. Yeah, so one of them will basically, when you read the data, it will optionally truncate it on return so you don't get those errors about the data being too wide. And the other one will automatically make that change that DB tool makes to the schema. So it will widen the field on the, yes. Yeah, you get a percentage that you can set it to. New-ish, but it's been around since 11.4, 5? Yeah. And Bob's talking about that tomorrow. So all right. Yes. Sorry? That doesn't work as well as you think it does. We can have a talk about that later. Private buffers on backups. Okay, Mike, go ahead. We know that, yes. How does that mix with a lot of your skips? That's true, because it'll never get.
It's at the bottom of the LIU.
Yeah.
It never makes the top of the LIU chain. Like I said, Gus is very smart.
Thank you, Gus.
Online backup does not pollute your buffer. Even though people think it does, the slowdown is because it's writing the output file. The slowdown is not because it's polluting buffer.
It does pollute the operating system.
Because the operating system guys aren't that smart. All right, I think we're out of time. So, thank you very much.